Matter, solid, liquid, gas, they all matter. Matter, states of matter, five states of matter. Fourth state of matter, boson, Bose-Einstein condensate, BEC, BEC first production, change in state of matter, sublimation, deposition, evaporation, condensation, favorable conditions for evaporation, pure substances, element, compound, mixture substances, homogeneous mixture versus heterogeneous mixture, solution versus solute, alloy, properties of solution, examples of solution, types of solution, unsaturated solution, saturated solution, concentrated solution, calculation of masses of a solution, questionnaire, properties of suspension, colloids, properties of colloids, Tyndall effect, types of colloids, different methods to separate components of mixture, filtration, handpicking, sieving, other methods of separation of components of mixture, evaluation and its application, chromatography and its application, centrifugation and its application, separating funnel and its application, sublimation and its application, distillation and its application, types of distillations, simple distillation, fractional distillation, purification, purifying solids, crystallization and its application, physical properties of a substance, chemical properties of a substance, physical change versus chemical change, Brownian movement. Matter. Matter is a substance that has mass and take up space by having volume. One pure substance, two impure substance. Solid. They have distinct boundaries and fixed volumes. They have definite shape. They have a tendency to maintain the shape when subjected to outside force. Gas, plasma. Gas ionization and plasma to deionization. Types of solids: amorphous solid, crystalline solid. They are isotropic in nature. They have irregular shape. They are pseudo-solids and supercooled liquids. They have irregular arrangement of constituent particles. They do not have sharp melting point. Example: glass, rubber, plastic, etc. Crystalline solid. They are anisotropic in nature. They have definite characteristic shape. They are true solids. They have regular arrangement of constituent particles. They have sharp melting point. Example: copper, silver. Gas. They exhibit behavior uniformity. There are states of matter. There are five states of matter. Primarily three states of matter. Okay, here, solid, liquid, gas, plasma. States of matter: space, kinetic energy, movement, force of attraction. Solid: low space, low kinetic energy, low momentum, and high force of attraction. Liquid: medium space, medium kinetic energy, medium momentum, medium force of attraction. Gas: high space, high kinetic energy, high moment, low force of attraction. Fifth state of matter: boson. In condensed matter physics, a boson condensate (BeC) is a state of matter that is typically formed when a gas of bosons are very low at very low densities is cooled to temperature very close to absolute zero, that is 0 Kelvin, minus 273 to 15 degree, or minus 459 to 67 Fahrenheit. Boson name originated from Indian scientist Dr. Satyendranath Bose and Einstein. Dr. Satyendranath Bose published a research paper in 1924 and sent it to Einstein, who then later talked about Bose-Einstein condensate in 1925. BEC condensate first production. 1995, Eric Cornell and Carl Wyman experimentally produced the first BEC condensate in a rare field gas of rubidium atoms at extremely low temperature. 1995, Wolfgang Kettler created a BeC condensate with sodium atoms. All three of them received Nobel Prize in Physics in 2001. Changes in states of matter. Sublimation. The process of changing a solid directly into a gas or vice versa without passing through a liquid state. Example, naphthalene, dry ice. Deposition. The opposite of sublimation, where a gas turns into a solid without passing through a liquid state. Example, subfreezing of air directly to ice. Evaporation. The process of changing a liquid into a vapor by heating. This happens at the boiling point of liquid. Example, drying of clothes. Condensation. The process of water changing from a gas to liquid. Example, dew and fog. Phase changes of matter. Gas to liquid, condensation; liquid to solid, freezing; solid to gas, sublimation; and gas to solid, deposition; solid to liquid, melting; liquid to gas, evaporation. Favorable conditions for evaporation. When temperature is increased, the rate of evaporation increases. When surface area is increased, the rate of evaporation increases. When wind speed is increased, the rate of evaporation increases. When humidity is increased, the rate of evaporation decreases. Pure substance. These contain only one type of substance. Example, diamond, sulfur, tin, etc. Element. A pure substance made up of only one type of atom that can be broken down into a similar substance by chemical means. Example, hydrogen and oxygen. Second, compound. A substance made up of two or more different types of elements that are chemically bonded together in a fixed ratio. Example, H2O, water. Mixture substance. These are combination of different substances. Example, brass, copper plus zinc; bronze, copper plus strontium. Homogeneous mixture versus heterogeneous mixture. Homogeneous mixture. They have a uniform composition throughout. The components of mixture cannot be separated through physical process. The component cannot be seen through naked eyes. The mixture is in a single phase throughout. Example, a mixture of milk and water. Heterogeneous mixture. They have a non-uniform composition. The composition can be separated through physical process. The components can easily be seen through naked eyes. The substance can be of two different phases, and we may see separate layers of substances. Example, a layer of oil in water. Solute versus solvent. A solution is formed when two or more substances are mixed in a uniform manner. A solute completely mixes in solvent and cannot be viewed through naked eyes. A solution is a homogeneous mixture of two or more substances. Example, liquid into liquid. Okay. Mixtures. Homogeneous mixture, separate, and heterogeneous mixture, combine. Example, liquid into liquid, water and ink; solid into solid, alloys; gas into gas, air; solid into liquid, sugar and water; solid into gas, hydrogen dissolves in palladium; liquid into gas, carbon dioxide dissolved in water. Alloy. An alloy is a mixture of different metals or nonmetals that cannot be separated by physical method. Example, brass, bronze, nichrome. Solute plus solvent is equal to solution. Properties of solution. It is homogeneous in nature. The particles of solution are too small, less than 1 nanometer. It does not scatter light. It cannot be separated by filtration. It is stable. Examples of solution. A solution of solid in water is a solution in liquid solution. A solution of sugar in water is a solid in liquid solution. In this solution, sugar is a solute and water is solvent. A solution of iodine in alcohol known as tincture of iodine has iodine solid as a solute and alcohol liquid as a solvent. Aerated drinks like soda water, etc., are gas in liquid solutions. These contain carbon dioxide and solute, gas as a solute, and water liquid as solvent. Air in a mixture of Air is a mixture of gas and gas. Air is a homogeneous mixture of a number of gases. Its two main constitutes are oxygen 21% and nitrogen 78%. The other gases are present in very small quantities. Types of solution: unsaturated solution. More solute can be added. Saturated solution. No more solute can be added. Concentrated solution. Large amount of solute is added. Supersaturated. Calculation of mass percentage of a solution. Mass percentage of solution is equal to mass of solute by mass of solution into 100. Question. A solution contains 40 grams of common salt in 320 grams of water. Calculate the concentration in terms of mass by mass percentage of the solution. 40 by 40 plus 320 into 100, that is equal to 11.11 percentage mass of the solution. Suspension versus solute. A suspension is formed when two or more substances are mixed in a non-uniform matter. A solution does not mix with a solute and can be viewed through naked eyes in a suspension, but not in a solution. Properties of suspension. It is a heterogeneous mixture. It scatters light because particle size is large, greater than 1000 nanometer. It can be separated using filtration method. It is unsuitable because sal, uh, solute, ge- solute gets settled down in solvent. Collides. It is a uniform solution of two or more substances. The particles are relatively very small at the and the solution appears as a homogeneous mixture. But it is not a homogeneous mixture and it is a heterogeneous mixture. Examples: foam, milk, smoke, detergents, gel, blood, paint, cosmetics. Properties of colloids. Colloids are heterogeneous in nature. The particles cannot be seen through naked eyes. Particle size between 1 to 1000 nanometer. The particles of colloids do not settle down if left uninterrupted, hence stable. It cannot be separated through filtration method, but can be separated through centrifugation. Tyndall effect. When a beam of light is passed through a colloidal solution, the particles of the colloid scatter the beam of light and we can see the path of light in the solution. Light source. Solution colloid suspension. Beam of light not visible in solution, visible in colloid and clearly visible in suspension. Example: solution water, colloid milk, suspension flour and water. Types of colloids: dispersed phase, dispersed medium, types and example: liquid in gas, aerosol, fog, cloud, mist; solid in gas, aerosol, smoke, automobile exhaust; gas in liquid, foam, foam, shaving cream; liquid in liquid, emulsion, milk, face cream; solid in liquid, sal, milk of magnesia, mud; gas in solid, foam, foam, rubber, sponge; liquid in solid, gel, jelly, cheese, butter; solid in solid, solid salt; colored gemstone, milky glass. Difference between different methods to separate components of a mixture. We can separate the heterogeneous mixture into their constitutes by means of physical methods. Filtration. Filtration process: glass rod, funnel, filter paper, mixture of insoluble solid and liquid, particles trapped by filter paper, residue, clear liquid filtrate. Hand picking, saving, large particles, save opening 2 mm, fine earth. Filtration is a physical separation process that separates solid matter and fluid from a mixture using a filter method. Hand picking, the method of separating substance in a mixture by hand when the components are clearly visible enough to pick. Sieving is a method of using a sieve to distinguish small particles from big particles. Other methods of separation of components of mixture: evaporation, It is used for separation of mixture of a non-volatile and volatile substance. Applications. It is used for separating colored components from the ink. It is used for separating salt from water. It is used for separating sugar from water. Chromatography. It is used to separate evaporation picture. Next, chromatography. It is used to separate solute that can dissolve that can dissolve in same solvent. Applications. It is used for separating color component of a dye. It is used to separate drugs from blood. Strip of filter paper. Spot spot of black ink on pencil line. Closed glass jar of water. Strip dip into the water. Water rises up, taking dyes along with it. Chromatography: different colored spots of dyes separated from black ink. Centrifugation: it is used for separating dense particles from lighter particles. Application: it is used to separate cream from milk. It is used to separate butter from cream. It is used to squeeze out water from wet cloths. Centrifugation of blood. Separating funnel: it is used to separate two uh, two immiscible liquids. Application: it is used to separate oil from water. Low density liquid, high density liquid, tap. Sublimation: it is a process that is used to separate a sublimable component from non-sublimable component. Application: it is used to separate aluminum chloride or camphor or naphthalene and salt. Cotton piece. Solid ammonium chloride. Inverted funnel. Vapors of ammonium chloride. Ammonium chloride. China dish mesh. Burner. Stand. Distillation: it is used to separate miscible liquids. The boiling point of the liquids must be sufficiently different. Application: it is used to separate acetone and water. Thermometer. Cork. Fraction, fractionating column. Cork. Distillation flask. Mixture of acetone and water. And water condenser. Cool water. Acetone. Types of distillation. Simple distillation: it is used when the miscible liquids have satisfactory difference in the boiling points. Fractional distillation: it is used when the difference between the boiling point of liquid is less than 25 Kelvin. It is also used to separate the components of air. Simple distillation: thermometer, water out, condenser. Thermometer, heating, distilled flask. Heating: distilled flask, thermometer, water out, condenser, water in, distillate, reverse flask, receiving flask. Fractional distillation: burner, vapor, distilling flask, cork, fractioning column, distillation adapter, thermometer. Cold water in, condenser, water out, receiving flask, distillate. Purifying solids. Crystallization: it is a process of formation of solid crystals from solution, melt or by deposition directly from gas phase. 1. Solution lamp. The pure solid is dissolved in a solvent. 2. The solution is heated to evaporate most of the solvent. 3. The hot solution is allowed to cool. The solid appears as a pure crystals. 4. The column solid is poured off to obtain the crystals. The crystals may be dried by pressing them between sheet of filter paper. Application: it is used to separate salt from seawater. It is used for purification of copper sulfate. Physical properties of a substance. Properties of a substance such as rigidity, color, fluidity, boiling point, melting point, density, and hardness, which we can observe, are called as physical properties. Chemical properties of substance. The chemical nature of a substance is known as its chemical property, such as its odor or its chemical composition. Physical change, chemical change. Physical change: it is a change that occurs without changing the chemical composition of a matter. It is usually reversible. New products are not formed. Some changes occur when heating or cooling it down. Changes have no effect on the chemical bonds of a molecule of a substance. Chemical change: it is a change of chemical composition of a matter. It is usually irreversible. New products are formed. Changes always involve absorption or release of energy. They have a direct effect on chemical bonding of molecules in a substance. Physical changes: in a physical change, matter changes form, but not chemical identity. Ice changing, ice melting, chopping wood, mixing gray and green marbles, shredding paper. And chemical change: in a chemical change, a chemical reaction occurs and new products are formed. Burning wood, rotting banana, firework, mixing vinegar and baking soda. Burning of candle is both a physical and a chemical change. Thread, chemical change, as it cannot be obtained again once burnt. Wax, physical change, as a wax can be used to make a new candle again. Brownian movement: it is a random movement of a particle in a medium suspended in a medium. It was named after Robert Brown after he discovered the phenomena in 1927. Brownian movement: blue, fluid molecule; red, suspended particle.